Hello, my name is Bart Verdonk and I'm Application Development Manager at Hach for the drinking water market. And so today I will present about our newest insights on reverse osmosis control and protection. So let us have a quick look on the content for today. We will start by looking at an overview of different disinfection methods, followed by talking about chlorination and dechlorination, chlorine measuring options, showing a trial result, and our newest innovations. Let's have a look first on the different disinfectants for water treatment in the overview as shown here. And you can see we have differentiated the pre-oxidation and post-chlorination applications. And some technologies like UV or chlorine dioxide are the strongest, but also the highest in cost. Chlorine is the most commonly used because it's a very effective oxidant and lowest in price as well. However, chlorine and also other disinfectants can have disadvantages like formation of byproducts, such as trihalomethanes, THMs. And in case chlorine is used for RO feed, the monitoring and control of chlorination and dechlorination is the primary goal. Here, the concern is, as we see, that chlorine will damage the membranes and shortening their lifetime and cause increased salt passage. Typically, a total of 1000 ppm hours of chlorine can increase salt passage by 50%, as an example. And we'd like to maintain always a steady low chlorine residual. And also the abscess of chlorine will cause premature biofouling of the filters. And the excess of chlorine may damage the membrane, shortening their lifetime. Chemical chlorine removal can be done by reaction by sodium sulfide or bisulfide or meta-bisulfide. And here the underfeed of sulfide can cause compliance issues and fines. And overfeed of sulfide can lead to extra costs of anaerobic biofouling. Absorption-based chlorine removal can be done by activated charcoal, better known as GAC. And here we see a concern is that channeling of leakage of water through the GAC columns without sufficient chlorine removal can be a risk of membrane damage and premature replacements. And also exhausting of the GACs can lead to chlorine leaks, and this is also a risk of membrane damages. Well, and here we see a general schematic of the RO filtration process, and we have summarized the challenges we are seeing. And this can be the underfeed of sulfide and cause permit violations. Underfeed of sulfide can also cause membrane damages from chlorine. But the overfeed of sulfide can lead to extra chemical costs, and it can also lead to anaerobic biofouling. And again, here the monitoring and control of chlorination and dechlorination is the primary goal to prevent the damage to the membranes. And as I just activated with the animation, you can also see the main parameters to monitor for the efficient process control. What options do we have to monitor chlorine? And in this overview, you can see the comparison of three principles. The ORP sensors have fast responses, but there are no direct measurements of chlorine. And they are influenced by process conditions like the pH and flow. The amperometric sensors have also fast responses, but they are also influenced by the matrix like the pH, flow, and the pressure. And you need to do frequent calibrations. The colorimetric sensors are direct and accurate and independent of the sample conditions, but they use reagents and are not continuous. And in order to make a selection here, we are using a 4-step selection criteria and summarize all the considerations. And these are related to specifications, expectations, and process conditions. And this enables us to make a well-thought choice for the right instrument for your application. Now, here is the result of one of our recent trials. we did with measurements on RO feed. A colorimetric sensor in the ultra low range and a ORP sensor were installed, and you can see that the flow and pH were also measured. And in the highlighted part, you can see the sulfite dosing was in manual and constant feed rate. While the ORP sensor was failing, the colorimetric sensor showed that the chlorine level was actually increasing. And in the graph, you can see the drift of the ORP sensor many times when the flow is intermittent. And yeah, this shows the independence of pH and sample flow of the colorimetric sensor and giving stable results. And in the last month, we have launched our new CL17 ultra low range instrument. A limit of detection of 8 parts per billion means that you can take precise control of your dechlorination process. The cumulative chlorine counter tracks chlorine exposure over time, and this data can give you insights into how much chlorine you are discharging over the time. You can also determine the potential for damage to your RO membranes. And in the table, you can see also the comparison between our standard CL17 and the ultra low range instrument. And finally, we will soon launch our new portable DR1300 FL as a first fluorometer. And I can tell you a little bit about the theory of operation for all these fluorescence tests. And this is being done by a specific indicator and buffer, which is added to a clean water sample. And once the analyte reacts with our indicator, a fluorophore complex is formed in the solution. And this fluorophore is then energized by the instrument's LED light source and then emits a fluorescent light, which is detected by the instrument's emission detector. And yeah, this will be able you to measure the total chlorine, free chlorine and sulfite from your grab samples in a ultra low range as well. And in this table we are showing here is that you can see the different tests and their specifications. And this brings me to the end of my presentation.